Good afternoon or morning, wherever you are, and welcome to the QEM Heroes webinar series. I'm Christine Wood, and I serve as the Assistant Program Director for the Heroes Fellows Program at QEM. And for more than 30 years, QEM has been a national catalyst for STEM education transformation and research capacity building. Currently, the QEM Network serves nearly 900 colleges and universities and reaches more than 8,000 individuals nationwide. This webinar is part of the HEROES initiative. The HEROES program brings together researchers with experience in the federal government to lend their expertise and support to the STEM research and education communities. Our fellows are here to provide tools and tips for navigating the funding landscape, developing STEM programs and partnerships, and improving talent retention in in-demand fields. We hope this series promotes engagement with our HEROES fellows and provides valuable resources to our participants. And as always, the webinar recordings and slides will be available in the QEM Resource Hub. By attending this webinar, you will soon be added to the QEM network and granted access to the Resource Hub. And I'm so proud to introduce our Heroes Fellows today. Dr. Frances Carter Johnson is an innovative problem solver with professional experience spanning commercial, academic, government, and nonprofit sectors, as well as multidisciplinary content, data management, and analytic expertise. Her technical areas of expertise include data science, AI and data evaluation, public policy, physics, and engineering. And James Smith is a retiree from the U.S. Department of Defense. In his 20-year career at DoD, he served as a site engineer, software engineer, systems engineer, project director, and an engineering and physical science researcher at the North Carolina State University Laboratory for Analytic Sciences. In these roles, he developed and refined expertise in artificial intelligence and machine learning programming, software engineering, and 3D graphics. He also advanced mission-critical research and partnered with students and faculty from minority-serving institutions in support of research goals. So without further ado, I will turn the floor over to our presenters.
Good morning, good afternoon, or morning, wherever you are. Thank you for joining us today for this talk on innovative data infrastructure models for teaching, learning, and research. And as always, our sessions are a time for conversation, a time for learning, and a time for sharing technical expertise. We try not to make it too technical, but we want you to know that this is a safe space to learn about some of this technical information and to share questions and share ideas as well. And we always like to start off. Feel free to put questions in the chat. We'll try to get to them as much as we can. We do have more material for this webinar than we have for previous webinars, so we do want to get through it all. If we find ourselves too close to the time, then we might stop taking questions and to try to get through the material. But we will start with some poll questions. This time we're using Mentimeter. So if you have your phone, you can scan the QR code there, or Christine also put the link to the polls in the chat. So we would like for you to answer those polls. And I am going to show, I'm not going to give the answers yet, but this is also where we'll hopefully see our results. So go ahead and submit your answers. I'm gonna put other just so I won't give away what. Let's see, is it gonna show? Mm,
Dr. Carter Johnson, you may want to share the code again because that flashed up there pretty quickly. So,
Okay, there you go. There's the code. And I might have to. Okay, so we have, it might not be showing my, we didn't practice this in detail, but let's see. So it showed us, no. We have about 7 people that 9 of you responded. 7 said IT staff, 5 university administrators, 3 faculty, 1 student, and 2 everyone. And we had 2 others. I was included in that. And the next question, are you able to answer the next question? There you go. So I'm not doing the correct, um, sharing the correct screen, but I can see it over here and I'll tell you all what the results are. And yes, please type your answers in the chat, um, because there is an other option where you can type, if you have an answer different from these, you can definitely type it in the chat. I'll go back to my slides. What information or training has your institution, if you're at a university or organization? Um, we'll talk a little bit more. So about 50%, about 2 people have responded. Guidance on using cloud-based platforms versus physical servers. We have 67% of you say that you've gotten information on that. But across the board, there has been some information provided. If you're faculty, there have been discussion or votes in faculty senate about what platform to use. So it's great to hear that there have been discussions about what platforms are being used. There have been emails about changing from physical servers toward cloud-based platforms. More than anything, there's been guidance on using cloud-based platforms versus physical servers. And there have been some self-paced courses for faculty around data infrastructure, and there have been faculty development courses on data analytics and infrastructure. And so that we really wanted to get a feel for where people were in terms of this topic. And so thank you for sharing those and participating in those. So an underlying belief that both James and I share around data infrastructure and data analytic understanding is data understanding by and for all. And you've heard funding programs being called that, AI for all, AI ready. And so where that comes from, when you work with data and you're comfortable working with data, you are usually of the belief that data analytic and infrastructure understanding is the responsibility of everyone in an organization. So everyone needs to know the organization's data infrastructure. From my time at the National Science Foundation, when I started at NSF in 2015, I was say one of 1 to 3, data staff. There were mainly program officers and administrative staff. There were very few people that were working on data. And so oftentimes in those environments, you are the data person. Everyone asks you every question, every piece of information, and no one else really is as aware of the data that's available and what questions can be answered. But as I stayed at NSF for about 9 years, we moved to having more data staff, and we led to doing training and developing evaluative and data analytic frameworks and data analytic strategic plans that really gave governance and gave information and understanding to almost everyone in the organization. So from the analysts to the program officers, and eventually we wanted to have more training for agency leadership. At a university, then that's not just the university IT leaders, but you want your administrators, your faculty, and your students. And excuse me for that arrow that didn't want to be in the right place. But why do you need this? You need to develop dynamic data literacy or data analytic literacy. What is that? We've seen over the past 5, 10 years, we've moved from big data or data science to big data to AI to cloud. Like there's been this huge push, and it's all related. It's all the data that's available is based on our digital age, on the internet being present. If we didn't have all of the information available in the internet and in digital spaces, we wouldn't be able to use AI so broadly, or it wouldn't be as prevalent in society in every part of our lives. But we've all moved along with it, and it's dynamic. So we, from a research perspective or from a educational education perspective as faculty, we need to be able to ask the right questions. We have a vast amount of data available at our fingertips, but are we using it? Are we fully utilizing it? Do we know what data to use when? And then what tools? The tools and the data are dynamic, but do we have some basic understanding of the structures and the tools to be able to use them effectively and efficiently? And as we see changes, as change happens, can we take that knowledge and kind of translate that knowledge to the change or to what may look like a big change, but may not actually be a huge change? So that's a belief that both James and I had. James, did you want to chime in on that at all before I move along?
Well, I guess coming from the industry I've come from, the amount of data that's coming in and the ability to process that data, everyone, like I think Greg put in there, IT staff needs to understand exactly what's going on. And I agree with that to a certain extent, but you also need the expertise in certain areas in order to handle all the different types of data and how it's being processed through the system. And so it's just having the amount of personnel to do what it needs to do is very key to a lot of these things. Yes, you need your staff to know what type of data is being stored, but not necessarily the expertise in it. And I'll probably get into that a little bit more in detail once we get to a couple more slides down the road.
Thank you. And so that's a belief that I've developed. Some of my former colleagues from NSF are here, and thank you for being here today. They've participated in some of these trainings and this shift of moving from really improving and increasing data analytic understanding for all. So that's where that belief came from. And as we were developing this presentation for today, I'm seeing that I'm not the only one. James and I are not the only people that have this belief. And we'll talk more about this symposium that was done by Amazon Web Services. Their machine learning university recently did a research and teaching symposium at Tuskegee. February 2020, in February of this year, end of February. So this is a really dynamic area. It's exciting to learn and just continue to stay ingrained in this area. At least it is for me, and I hope it is for you all to bring that excitement. But there are a lot of resources as well. So, some of the findings from this webinar, from this symposium, I haven't been able to find a lot of findings, but there's a LinkedIn newsletter by Dr. Calvin Briggs, who is a part of the QEM community from Alabama. And so this LinkedIn newsletter reminds us or points out some of the findings from this symposium that technology is not going to transform our institutions, right? It's not AI by itself. It's not data science by itself. It's the culture, the governance, and the faculty development will determine whether technology actually improves student learning or research or improves the university at all. So to guide institutions in our network, HBCUs, MSIs, there is a project that I have some slides on about later, but it was really key to bring it here, bring it in the forefront at the beginning of this presentation. But this project has produced a digital learning infrastructure taxonomy, and they've produced a digital learning assessment guide for universities to assess where they are in moving to digital learning or into being AI ready. And the four domains are foundation, institution, faculty, and students. So reminding us that you have to have the data and the architecture as the platform, but the institution has to be present and provide leadership and governance, the policies. The faculty has to have the instructional capacity and some professional development. There needs to be some understanding there. And the students, we are saying engagement, advising, and support systems, but this is implying understanding, some level of understanding on all levels. So not just my belief. This is a belief that's going forward and being utilized by many of the HBCUs and institutions in our community. So wanted to give you some of that why, right? Some background, some foundation before we just dive into the technical. And you might not use the words data infrastructure as often as James or I or, some tech people, but you know what data infrastructure is, right? So so we'll talk about it a little bit, and then I will like for you all to engage. What is data infrastructure? We often hear to it referred to as a stack because there's the multiple layers that allow us to do data analytic work and connect different data systems for an organization or an institution. And those stacks or layers are the first one we'll talk about is type. So you can have either a physical infrastructure, a cloud infrastructure, a hybrid that's a combination of physical and cloud, or an integrated infrastructure. What are the components of your for that level, your type? This is where we hear the words data center or server or router or storage devices. So if we think about it, our homes are a very simple data infrastructure, right? Because you have a router, or you may have two, or you may have a router and an extender, and then you have multiple devices that are on your basic wireless network. Your laptops, your phones, your tablets, your computer, or not your computer, but your printer, your fax machine. If you've ever had the problem that I have, like, why won't my printer print? Because it's on the opposite network. The computer and the printer are not on the same right network if you have multiple networks. So that's that first layer, and we use that term all the time. It just gets to be more complicated when we think about an institutional organization. The next layer, the software layer, where our data is stored, the software that we use, so databases, data warehouses, ETL systems or tools, and data lakes. Now that we're thinking about cloud servicing, our data is often stored in data lake as opposed to databases. And then we get into the data security and the governance, which is an area where most users are not involved in creating, because you might create encryption on one file or some files or a set of data, but you're not creating the firewall. Your organization, your IT staff is responsible for creating the firewall, but then you need to operate accordingly within those firewalls and even the policies, right? Whether it be a federal organization that um, came up with the policies of using or not using AI, or how to use AI, or how to use AI in funding, or how to use AI in your work, and then processing frameworks. These two, and I see your hand, Tarina, are um, Apache Spark. They are for processing large amounts of data, but there is a processing framework um, to data infrastructure. And I'll just finish this, let people type. Tell us your institution's infrastructure type in the chat, or tell us if you feel like you know it. And when I say infrastructure type, is it physical? Is it cloud? Is it hybrid? Or is it integrated? And it's okay to say you don't know, but I think you know some information, right? You've heard whether your institution is using AWS or Microsoft Azure or Google. So if you are, then there's some cloud there. You're using some cloud services there. Go ahead, Tarina.
Question, well, not a question. Recommendation. Can you explain what ETL stands for and what a data lake is?
An ATL system is an extraction tool system where you often um, are pulling data to analyze the data. Sometimes you have large databases or large sets of files where you can have a computer system that will analyze the data for you. When you are some of us are more accustomed to analyzing data in R yourself, or in Stata or SPSS yourself. My experience with the extraction tools, the ETL tools, is you would create the algorithm, you would create the the system to analyze the data before, and you would extract the data and run it through an ETL system to analyze the data. That's my experience.
And you also want to keep in mind, and also you want to make sure the data is moving through the system destination reliably, no issues. So if you're feeding it in, you want to make sure it's getting to the appropriate destination. So that's basically what you use for the extract, transform, and load for as far as ETL.
Thank you both.
You're welcome. And Jennifer chimed in. Yours is a hybrid system, because you can store and access on the cloud as well as the desktop in your office. Thank you. Thank you. Thank you. We'll move to the next slide. So let's talk about why a little bit more why the importance of data infrastructure understanding for teaching and learning. And I broke it down into educational and workforce outcomes or, workforce of preparation outcomes. Of course, as, faculty, you want to effectively integrate technology to enhance already proven learning strategies. I won't say that technology and AI and all learning should happen via technology now. We know that there are proven learning strategies. The traditional learning strategies are also important and are proven to work. Our students learn by writing things down, especially I think in math and chemistry. So I'm not a proponent of learning everything from slides or from, a learning system, but the incorporation of the two I think is important for the group of students that we're dealing with for this generation and for the next generation of students. They're so accustomed to digital technology that effectively integrating the two is important. Also, being able to really understand your infrastructure of where your data is for courses to really get almost real-time student learning and curriculum effectiveness evidence from some of the data that is collected from learning management systems or from our courses. We can understand how students are learning earlier and try to adjust or adapt or reach out to those students. Also, updating our curriculums to use data repositories. So, whether it be biological research or psychological research, chemistry research, HIV research, there are data repositories that are out there, and that might need to be another webinar where we talk about data repositories that are available um, for research, but are those data repositories being incorporated into curriculums for students, whether they are going to work in labs or whether they are going to do research? Are they aware of the data repositories or even the ways that laboratories can be simulated nowadays? Another topic, but really updating our curriculum to make sure that students are aware of these alternative analysis opportunities and also using them in education. And then the workforce outcomes. We talked about dynamic data literacy being a universal skill. No longer is AI understanding or data analytic understanding just limited to computer science. It's important for STEM fields, but it's also important for humanities as well. English majors, if you're going into communications or being a journalist, there is a need to understand data, whether it be Twitter data or video data. So and in order to appropriately use that data, some data literacy, dynamic data literacy, and foundational infrastructure understanding is important. For many of us who pivoted, right, and you've left the federal government or wherever you are, and you apply for different jobs in different places in corporate America. Um, AWS, Microsoft, they have trainings on their data infrastructure. So as you prepare to, if you want to apply for a job with Amazon, it looks really good to have an Amazon certificate on their data infrastructure, and they offer those trainings, and you can do those trainings. But also, LMS systems that we are learning management systems that you had in your organization to learn from, they are present in the job market, not just for professional development, but as early as an application. There are assessment tests that anyone going into the job market, oftentimes now with large corporations, will have to take before you can even be considered for different positions. And so having students be aware and understand these requirements of the workforce, both through our courses and through our career development centers at universities, is important to have them prepare for the workforce. And just a quick graphic of different data infrastructure tools for teaching and learning. I know everyone's familiar with Blackboard and Canvas. Google Classroom might not be widely used. Moodle might be obsolete now. Data visualization. Many universities are providing Power BI and Tableau to analyze not just administrative data, but also student data. There are formative assessment tools and polling tools. And when we come back to the workforce, the online job assessment pretest, one company is Talogy. There's also virtual reality training that is happening in many jobs. So just that is a part, being prepared for the workforce is a part of what we want our students to learn with QEM institutions. So thinking about that and that understanding of data infrastructure as preparation for that. Why is data infrastructure understanding important for research? For research effectivity, if efficiency and productivity. Your labs, as we think about organizing your data and archiving your data such that data is not lost or stored, and organizing it both on the individual level as well as for your students, the automatic backups that come, and being able to share and work across larger data sets then is important for enhanced collaboration and impact. And then data governance as well, and addressing funding agency data sharing requirements. Some agencies are requiring data sharing for reproducibility and scientific integrity. It also helps to improve or decrease fraud and errors and helps with validation of findings. We know that there's a lot of change and we want to have long-term data preservation as well. So multiple reasons for data infrastructure understanding for our research. And from a very, simple standpoint, you're in an organization, you've stored your data, say, on a server or on a drive for years, and now we're having to shift that, right, to the cloud or in Microsoft SharePoint, but really having an understanding of where that data is, where it's going to be stored. We're doing less and less training. Many organizations aren't doing training on it, but this is almost encouragement for us to pursue some of that training and basic training ourselves so that we can be aware, or to take it if your university or organization is offering it. This slide just lists the 5 major types of common university data infrastructure models. Many organizations started with the 3-tiered data architecture model and are moving to the modern data stack. Many universities, Harvard and Washington University, are using the research data management models that corporations are using. And then there's some federated data models and standardized common data models as well. I wanted to present those. We can talk about them more later when we get into questions. But James is also going to go into where people are moving. More people are moving from the 3-tier data architecture to the modern data stack that is often a hybrid data infrastructure model. And James, I'll turn it over to you.
Next slide. So basically, you're dealing with 3 areas. The main areas is public, hybrid, private. If you're looking at the public cloud, you're normally dealing with Amazon, Google, Microsoft. Plus, there are a couple of smaller ones such as Red Hat, Oracle. Depends on what you're trying to do. I mainly worked in the private cloud, meaning our organization didn't want any data coming in and out, so we built our own little internal cloud. The problem with doing it private is you only have limited resources. Eventually, you're going to run out. And so, how do you increase the amount of resources? And the hybrid is supposed to be a combination of those two. A good example of what's going on, especially within the federal government, is they just signed the contract with Amazon, Microsoft to do their cloud services, and basically for DoD. And that's going to be a combination. And I'm curious to see how, especially if they let certain agencies use it, how they're going to get the information from an unclassified to a secret or top secret network. So that's going to be interesting on how they use that. But that would help solve as far as storage capacity, being able to load up as much data as you need by using some of these publicly available cloud services that are out there. And it does come with a cost. And I'm sure Amazon and Microsoft are charging an arm and a leg to do a lot of these things. So next slide. So some of the benefits as far as public, I mean, it's accessible to anyone. You pay as you go, but some of it is free. I know Amazon, they give you up to 700 hours a month. If you know you can keep yours below that amount, you probably won't have any issues. Plus, they give you different types of levels to use it, such as EC2. If you just need to store videos and images, you got the S3 bucket. Or if you know what type of server you want to run, they have other things you can use for that also. So the benefit of the public, they try to make it accessible, easy for anyone to load up their information. The private cloud, like I said before, it's restricted. It's mainly for internal. You have more control as far as security. You can put your own security platform on how you want to manage all that stuff internally. And normally, if you're doing it internal, we tend to hire a bunch of contractors to come in. We hired a bunch of contractors to come in. So we'll see. The hybrid is a combination of both. Like I said before, you get the benefit of you can make it private, but if you need more resources, you can always add more resources in order to continue doing the type of processing you need to do. Next slide. So you got all the different clouds. So you have the infrastructure as a service, platform as a service, software as a service. And depending on what you're trying to do within your organization, is going to determine how much control you want to have. If you're using software as a service, they do everything for you. And just think of software as a service as, say, like you use in Microsoft 360, Google Docs, or you go in, just start typing, or anything else you want to put in there, it's already ready for you. Platform as a service, normally where I worked in, where I want to put just write code. So I'm able to install my own application, my own storage system, and all I had to do is just develop it. We had network engineers who did the infrastructure, and basically they controlled the operating system. We mainly worked in Linux, so we wanted to be able to do that. But the problem with the infrastructure, that gets very expensive, especially when you're doing machine learning. The GPUs come into effect. You really need to know exactly, if you're going to do infrastructure, you really need to know exactly how you want to set up. Uh, I was at the agency before they start switching over to the cloud back in 2011, 2012, and everything was a three-tier. So we controlled the servers, the databases. We wrote all our code internal. Server breakdown, we got all the new servers. They got tired of that, so now they started switching everything to the cloud, and this is why you see the contract with Amazon and everything else come into play, because they've been doing it for a long time. They're experts at it. We was trying to do it. They do it better, and might as well pay the people who does it better. Get the benefit, get the bang for your buck. Okay, next slide. So here are all the different as a service type of platform. You have software, which is pretty much 90% of America in the world works in that area. The functional as a service is if you have something that's unique that people want to use, such as if I have a game engine and I just want to render a particular object in Gerard shading, and I just make that function available to where you put your information in and it just spits out that one piece. Of course, you have the database as a service. That's your Oracle. Of course, Amazon is part of that also. Platform as a service. If you're a developer, that's pretty much where you're going to work in. Uh, then you got the infrastructure. Now, this here, the last one is the one that I forgot what the ST as a service is. I never worked in that. That's fairly new. But I do find it interesting. That's the storage. Okay, sorry about that. That's the storage. If you have Dropbox, I normally worked in the S3 bucket, but if you have a bunch of videos, images, you're not storing that in a database. You normally in your database, you store the name of the file, but you put the images in a central location and you just call it when you need it. So you got your storage as a service. Then, of course, the infrastructure is your EC2. your Google Compute Engine, and the Rack Stack. That's if you know what you're doing, you know exactly how much RAM you need, what type of GPU, the operating system. If you understand all that, then of course you want to do your infrastructure because that gives you the most control, but it costs the most money. Next slide. And so basically here, we just want to look at how higher ed can use a lot of this. Like I say, working on NC State campus, we were mainly in the platform as a service. We was doing a lot of 360 and Google Docs. But when we started doing AI ML to help train our models, we went more into the infrastructure as a service. And so, as an organization, as a higher ed, we really got to look at what exactly are you trying to do. So, to Greg, what Greg was saying, yes, the IT team needs to understand it, but you as an individual, if you know you just want to store documents or you just want to be able to do your simple images, then you sort of know, hey, I just want to do Photoshop. I just want to write my documents. That probably fall in line as a platform as a service. But if you want to just write code, then more than likely you're going to be in that code lab where it's sort of like, okay, instead of as a platform as a service, you may do the infrastructure as a service. But it's all based on the experience of your IT team also. So a lot of this stuff is freely available for you to try, but you also got to keep in mind that over time it does cost money and you run out of space. If you're storing a bunch of documents, you're going to run out of space. So just keep that in mind when you're working with these tools.
I have a quick question,
Okay.
Jane, from the agency perspective versus the university perspective. In the agency, you know, um, different groups of directors didn't really have any control over this. But from a university perspective, is the university making a choice, but some labs are also able to make these choices in the university, you know,
In our
situation?
case, the way the agency separated everything, we were able to make a choice based on our organization in that agency. So at the university level, like I said, I never worked in the university. You may have an IT department, and within that IT department, say, hey, we have a cloud system set up. What exactly are you trying to do? And based on your feedback to that IT person, he's going to set it up a certain way in order for you to do your job. Where in our case, if we have petabytes of data coming in and we want to process that data, we needed a little bit more control in our organization. Now it does come with a limit because everything costs. So the the agency as a whole may say, give us a certain amount of money. Let's say, hey, here's what you can do with this money. And I know I got a petabyte of data that's coming in that I needs to train my AI ML model that my models on. I'm gonna know I'm gonna need a GPU. So right off the back, me knowing I need a GPU, I may need four of them. I'm gonna need the infrastructure as a service because I need a little bit more control rather than as far as setting up my platform versus just give me the software as a service, the platform as a service, and I just write some code. They may put a GPU on there as a platform, such as Google Colab. They'll give you a GPU, but it's just one. And so it's all about what you want to do. As far as the agency, you have a limit on what you can do because based on the priorities of that agency and where you fall in line, you are going to be limited to what you can do as far as processing and setting everything up. But if you're dealing with higher ed, I'm assuming you have an IT department and you talk to your IT department and they give you the resources based on what you give them. But that goes back to like what Greg was saying. You got to have some IT need to understand, but you got to be able to express what are you trying to do to a certain point. And then they'll say, okay, all you need is this. Like if you say, well, I want to use Photoshop and I want to store the images. Okay, that's just a software as a service, which Adobe went to back in 2012 to charge that. So that's just a fee. It's coming down to what exactly are you trying to do? And can you explain that to the person who got to set it up?
And that's where I think the understanding comes from, especially if you're using this for research and
Right.
you're trying to be innovative and you want to do AI research, then you have to have some type of understanding of the platforms and your intended goal, right, with the
Right.
data or the platforms. So that's why you need the context and you need your IT staff, and you need to communicate. You have the context. Your IT staff may have the technical knowledge, but increasing your technical knowledge is important. So go ahead, Tarina.
And I just wanted to piggyback off of that and say, everyone who submits to grants or for proposals, there's a data management plan requirement. And so you have to understand what you're going to do with your data, how you're going to handle it, process it, how you're going to keep it private or whatever, especially if you're dealing with human subjects. So this is a very important discussion. It's not just something you can brush off to IT, in my opinion. I used to be in IT, and you can't just say, okay, IT, tell us what the data infrastructure is. Well, it depends on, you may not be using the entire data structure. So you have to understand what it is you need so that we can then explain to you or write up for you what that looks like. But you also have to know your own requirements in terms of the grant you're writing for and so on and so forth. So this is a very important discussion.
And there is help out there. We're not going to just leave it on all of this information. There is help for this community, us and others. There are some cohorts, some things going on. You want me to move to the next slide, Jane?
Oh yeah, that's fine. Okay, so now what we want to look at, I'm just going to look at the first three, the big players in the room, AWS, Google Cloud, and Microsoft, and just do a little comparison as far as their data infrastructure and how are they ready for AI. You go to the next slide. So when you're thinking about AI readiness, you thinking storage, data, how can they process the machine learning and it's available in real time. Now, real time is the one that interests me because we had a lot of videos coming in and we want to be able to process in real time, analyze the information in those videos, and then spit out relevant information to the analyst. So what can you do in a short amount of time to get that out as quick as possible? And looking at the three players in the room, they all have their benefits and they all bring certain things to the table. But these six are the main things you want to try to figure out when you're doing your data. Okay, what exactly do you need and what are you trying to do when you start looking at AI readiness for your platform? You go next slide. So here's another one as far as as far as data storage. They all store, but it's all about speed, in my opinion. We use a lot of AWS with the S3 bucket, but like I say, they've been around the longest. Uh, Google is good, in my opinion, when it comes to pushing and receiving. But Amazon, when it comes to just streaming real time and processing your data, it was no comparison as far as, and that's probably why you have companies like Netflix storing their videos in AWS to push it out to every individual. Now, vector embedding, that's an interesting one because when we're looking at images, you want to break that down into numbers and you want to be able to store that information in a database and be able to pull that out, and whether you want to convert it back to an image or vice versa, uh, being able to process those numbers in real time. Google hands down was our choice in that matter, but come to the object streaming AWS, but it goes back to what are you trying to do. This is where you have to understand exactly what you're trying to get out, do your research, vector embedding, data, objects. It's, I think it just boils down to I'm more interested in streaming, analyzing images. I have a bunch of text data. And from there, your team should be able to make a decision. Okay, this is who we're going to go with. You can go to the next slide. Now, as far as AI ML, um, it's about resources and how much resources can you use in a short amount of time. And Google Colab, I keep saying Google Colab, but Google Cloud gives you a lot of access to their GPUs, but as far as processing, we always looked at AWS for processing all the data that's coming into the agency. Uh, Microsoft, they're fairly new and they're building their infrastructure based on a lot of their Microsoft products. And if you're not familiar with their products, as far as Google, I mean, as far as being able to keep that stuff secure, you need to really pay attention when you use it, go with the Microsoft product. And I'm just saying this from why we didn't use Microsoft and why we always focus on AWS and Google. But they're all capable of doing what you need. It's just a matter of who do you have the trust to do your compute power, to handle your compute power. And Google can give you as many GPUs as you need, as long as you got the money. Next slide. Okay, so here's some examples of each one. Of course, you got the auto ML, experiment tracking, and bias and explanation. Which one handles which one better? Like I say, the Vertex AI is Google go-to. I haven't touched that a little, but the SageMaker, that to me, if you're gonna go with anything as far as storing a bunch of text associated with images, hands down, you're not gonna be able to get a better option than that. Now, Azure, I would say if you're going to use the Microsoft database, everything Microsoft does, they make it to where if you go Microsoft, you're stuck with their Microsoft products. Uh, if you're more into the open source or you want to use a lot of your Ubuntu products, uh, Google and AWS is probably the way to go. You can put Ubuntu on Azure, but it's not going to function the same way. Plus, you're not going to get the type of security as you would with such as AWS. And I'm just saying this because this is just my opinion and from when I worked on it when I was at the agency. Next slide. Okay, this is the data pipeline what we were talking about earlier. They all offer different things. It depends on the flow. Most our agency was a Microsoft, so going in and out was simple as it can be when you're dealing with the documents and certain things associated with Microsoft products. But when it comes to dealing with audios and videos and just pure text, I don't know if you're familiar with the Richard Nixon tapes that's publicly available, but being able to process those tapes in real time and get textual information from it, uh, Google hands down performed much better with the text, but when it came to just processing video and being able to handle the number of connections to all the different type of data being fed into a system, Amazon performed way above all the rest. Next up. All right, and so bottom line, you got the Microsoft, you got the AWS, and you got Google Cloud. It depends on what you're trying to do and how you want to do it. It's benefits to either one. Uh, it's really comes down to okay, the type of skill set your team has. Using SageMaker versus Vertex is they have their benefits, but each one has its benefits, pros and cons. But it really comes down to your budget, how much you're willing to spend, what's free, what's not free, and your timeline in order and how fast you're trying to get it done and how user friendly is it is to get set up. Okay. Like I said, you want to choose your AI cloud platform. I don't think it's a wrong answer. If I was to pick, I would always go with probably AWS, but Google Cloud tend to be more open source friendly versus any of the other systems. But if you're a true blue Microsoft, everything is Microsoft, then of course you're gonna go with Azure because, like you say, if you're using Microsoft 360, everything is already in that cloud. It just makes sense, and they tie everything together. So, but it really comes down to the type of data, what are you trying to do, and what kind of data you have, and that's going to dictate which platform you go with and your budget. They all offer free tiers. Some are different than other. It depends on if you want a different type of operating system. If you, like I said, Azure, Microsoft, yeah, you can go for it. But if you're a Linux person, more than likely you're going with Google or AWS. So it all comes down to the type of resources you're looking for to set up your infrastructure. So with that, I'm gonna pass it back over to Francis.
And we know it's a lot. And we know it's a lot of graphics with scores, right? Readiness scores. But you could say you saw it here first, maybe, if you haven't seen it. And so, as we've all, a lot of times the first time you see something is exposure, and learning and hearing about it the first time, but you can always come back, and have these discussions. So, um, that's the point of this initial webinar. If you'd like to see more, get more in depth, then let us know. We are reviewing the feedback that we get from each of our webinars and moving accordingly. So, as we said, there's help within, from QEM fellows, but there's also help out in the community. And so wanted to provide some of those infrastructure innovation examples and resources for the QEM community. There's a nonprofit called CompleteCollegeAmerica.org, and they have been funded by the Gates Foundation, Bill and Melinda Gates Foundation, to do a couple of things, but they have a HBCU digital infrastructure that started around 2024, had six colleges, six HBCUs, Coppin, Virginia State, Langston, Mississippi Valley State, and two more that I don't want to call incorrectly, but they are in a cohort, and they are working on digital infrastructure in a collaborative way. Uh, Coppin State and Virginia State, maybe you all already know, are currently being considered leaders because of the innovation and the changes that they've created on their campus and the focus for those particular campuses. And they're working with the other four campuses. But their results are being shared broadly and being used broadly. The results are that digital literacy assessment test or digital readiness assessment that I talked about on a previous slide. So the DLI taxonomy framework and the DLI assessment tool. If you go to this website, you can get access to their DLI assessment tool for your university or for your lab to think about where you are. And then there's also a report. The reports that might be a little dated because they were 2024. We know a lot has happened, and it's interesting to know where this effort is with them for now. But it was great to find out that this effort is connected to others. Some QEM fellows and maybe others on this call may have attended some workshops. There was a workshop and report in 2025 by Aleutian and Houston Tilliston University and the United Negro College Fund that looked at HBCUs, artificial intelligence, and a new vision for higher education. Houston Tilliston is leading in this area as well. They had an HBCU AI conference and training summit in March of 2026. I know Quincy Brown was a speaker there, and some of our other fellows may have gone there. So, and then there's the AWS MLU Machine Learning University Research and Teaching Symposium that Tuskegee had. And um, James talked about in a previous webinar, our webinar on using data, how AWS would provide these services to some grantees for the agency that he worked for. So this is along that same thread, James.
Oh yeah, basically the Laboratory for Analytic Science. If you're selected as a performer, they give you access to AWS, and they give you an EC2 instance for you to set up your infrastructure to do your research. And research normally goes from January to December. Then at the end of December, you come to a symposium to showcase what you've done for a year. And this is just for 1 year, and then you got to reapply the following year. But if you are selected at the Laboratory for Analytic Science as a performer, they give you AW, access to AWS at no cost. So all you got to do is go in, set it up however you want to set up. You need a GPU, they give you a GPU in order to do your research.
It's perfect. The results, so those are examples of that's an example James talked about of some federal funding that is still available to build your infrastructure. This meeting that was at Tuskegee and the LinkedIn newsletter by Dr. Calvin Briggs, I'm not taking any credit for this. I saw it on his LinkedIn page. It's definitely out there, but it was good to see some results. There are several cohort-based opportunities from that symposium that faculty in the QEM network and in our QEM community, maybe even Heroes Fellows, can participate in. So I've listed them there. Take a screenshot if you want of this slide. The slides will be available afterwards. But if you're interested in the Educators Consortium, AI Impact Network for Dean and Department Heads, Tech Visionary Collaboratives of CIOs and tech leaders, or the Transformation Alliance, these opportunities are live. I checked all of them. And so you can explore these opportunities, right? To be a part of a community that is working on this. Um, and then just to quickly talk about our upcoming data analytic and AI series, we in May will focus on using synthetic data for intelligence and other research. We're planning with Quincy Brown a fireside chat on AI and ethics and strategy for the QEM community. We don't want to leave out the concerns we have about education or the concerns we have about justice. And it was really great to hear that some of these symposiums have the same focus, but we want to chat with the QEM community about ethics and strategy in June and about AI and education in August. We do want to talk about all different types of AI funding opportunities, federal, private, public, and state in July, and then thinking about AI in classrooms and preparing students to use it effectively and ethically in the university and beyond. And then we have some hands-on workshops that we're hoping to plan as well. Let us know where you'd like more information, and we have a few minutes for questions, I think, comments.
And please feel free to raise your hand to come off mute. We have the chat open and we also have a Q&A box. I have one question. We talk a little bit about AI governance in this talk, and I'm wondering across institutions how varied it is to have rules and regulations around responsible AI use. Is there a common kind of ethical principle that guides AI governance across institutions, or is this something that's kind of developing as we speak?
I'm thinking it's developing as we speak. There are the FAIR principles for research. Um, and then yeah, there are the five ethics of AI use for research that we talked about in our first webinar. Um, being transparent, um, and being transparent, letting people know, checking your sources. I'm not saying them correctly, but there are some. I don't know what of course, in these situations, who's the mandate, who's watching, who's making sure that you follow these principles. But in some places they are. There are checks and balances for checking how much, AI was used and encouraging people to use it appropriately.
I know we didn't have any of that. As long as we didn't use American citizens, we were good.
And I will say that I don't know about the other, but at SACS, they do have a basic guideline on AI use. And there's two documents, and I forget the titles of them that relate to AI use at universities, and some basic guidelines. And then, as Dr. Carter Johnson said, a lot of schools are just now developing their policies and restrictions and procedures, and some aren't doing anything with regard to it. They're just kind of those latecomers who are waiting to see what everybody else does, and or waiting on mandates from governing organizations. So it's a varied group.
Great question, Christine. Thank you all for your attention and for coming in and listening. Let us know if you have questions. Oh, we forgot that last slide. Sorry.
Thank you so much for attending today. And thank you to our presenters for an informative and in-depth presentation. We appreciate your attendance and we hope to see you at a future QAM webinar. Thank you. Have a great day, everyone.